Hello everyone, this is Q, and in this video we will go over the concept of prime factorization. Our goal through this process is to list all the prime factors of any given number. Remember, the prime factor tree only represents the prime factors. There could be many factors for any given number, but these prime factors are the smallest factors, apart from the number 1, of course. So let's look at a few examples and see how we can derive the prime factors from these. So our first example is the number 60. One thing that we need to be very careful is the way we draw the prime factor tree. It should be clear so you don't get confused. So let's start with number 60. One of the easiest ways that I find to draw the factor tree is to start with the number 2 if it's an even number. So because 60 is an even number, we can start our first tree with 2. So 60 divided by 2, 30. 30 is also an even number, so you can do another 2, 15. Now 15 is an odd number, but it's a small number, so you could easily come up with 5, 3. 2, 2, 5, and 3, all of them are prime numbers. So you can't go any further than this. Now, what does this tree show? It basically means is that these numbers is where the factorization stops. Now, if you do 2 multiplied by 2 multiplied by 5 multiplied by 3, it will equal to 60, which are basically these numbers. Or you could also do just say, let me just use a different color. So you could also just go with one line. 2 multiplied by 30 will also give you 60. You could also go with 2, 2, and the other line. 2 multiplied by 2 multiplied by 15, 60. Or, as we originally did, 2, 2, 5, and 3. Remember, you can't take 2, 2, 15, and 3. If you are to look at the prime numbers, you have to go to the last numbers of every branch. And if you want to use the same level, then you use all the numbers of the same level and the last numbers of the other branches. Now let's look at our second example. It will make things a bit clearer. Now, as you can see, when you start with 2, the tree can be a little longer, as if the number is bigger, you will get more branches. So with 100, let's start with the number 20. So it gets a bit easier. So 20 be 5. We got our first prime. The number 20 can further be divided by 5. 5 times 4. The number 4 can go to 2 and 2. So just like the previous example, what this means is 5 times 2 times 2 times 5 is equal to 100. So remember, you could just take same level, or you could go with 5, 4, and 5. So if you're taking 5 and 4, then you also have to make sure that you go with the last number of any other branches, which would be 5 in this case. Let me clear up a bit so you can see. And the last is, you could also go with 2 and 2, but at the same time there are two more branches, so you would also take 5 and 5, which we did over here, and all of them should equal to 100. Let's look at our third example, 352. So we can always just keep going with twos. However, that tree will be much longer. So what we should do is look at um, a factor which will break this number down much quicker. So in this case, say we go with 16. 16 times 22 will give us 352. So now 16 could be 2 times 8. 22 could be 2 times 11. 2, 2, and 11 cannot go, like we can't go any further because all three of them are prime numbers, but 8 can be simplified further. 8 will become 2 and 4. 4 would become 2 and 2. So the same rules would apply. If you multiply 2 times 2 times 2 times 2 times 2 times 11, your answer would be 352. Or you could also go 16 times 22, you'll get the same answer. Or you could do 2 times 8 times 2 times 11, you'll have the same answer. Or you could do 2 times 4 times 2 times 11 times 2, you should get 352. Or basically just use all the prime factors, and when you multiply, you should get 352 as well. So this is the process of prime factorization. As you can see, you can take any number, any big number, and break it down into smaller numbers using this process. Well, I hope that this video helped make this concept easier. Thank you for watching. Goodbye. Thank you for watching my videos. Please make sure to hit the subscribe button and the bell icon to follow.